purpose of this program is to acquaint international service personnel with the operation, maintenance, and troubleshooting of Holly Prestolite electronic ignition systems used on 1974 and 1975 international vehicles. Various electronic ignition systems have been offered on international light line vehicles since 1970. The Holly Prestolite system was introduced in 1974. It was standard equipment on all light line vehicles equipped with 392 cubic inch engines sold federally, and standard on both 392 and 345 equipped vehicles sold in California. In 1975, an improved version of it became standard equipment or optional equipment on all vehicles equipped with 4196, B304, B345, B392, MV404, 446, and B537 engines. Holly Prestolite electronic ignition, technically called breakerless inductive ignition, is the result of years of research toward finding an extremely reliable ignition system able to cope with the increased demands of modern emission-controlled engines. This ignition system has undergone extensive testing and delivers outstanding performance over a wide range of operating temperatures and conditions. The system is centered around the electronic ignition control, which is a completely sealed solid-state unit. Its component parts are permanently sealed in an aluminum case with a water and vibration-resistant compound. The ignition control unit electronically makes and breaks the ignition's primary circuit, shown in red, in response to triggering signals from a sensor in the distributor to the wire shown in blue. The distributor is similar to conventional distributors, except for a sensor and trigger wheel, which replace the usual contact points, condenser, and distributor cam. There are no parts in the distributor that require periodic replacement. The system utilizes an ignition coil of standard construction, a standard distributor cap and rotor, as well as conventional interference suppression secondary ignition cables and resistor spark plugs. Because the primary ignition circuit is regulated within the electronic ignition control, a ballast resistor or resistance wire is not needed in the system. Breakerless inductive ignition operates much the same as conventional inductive ignition systems. The major difference lies in the fact that the conventional breaker points, condenser, and distributor cam, normally used to switch on and off the current going through the primary windings of the coil, are replaced by the electronic ignition control, sensor, and trigger wheel. A conventional inductive ignition system stores energy in the coil by generating a magnetic field in the primary winding of the coil. The field is built up by the passage of current through the primary winding when the points are closed. The length of time the points are closed is called dwell and is measured in degrees of rotation, referenced from the distributor cam. When the current flowing through the coil's primary winding is suddenly interrupted by the opening of the breaker points, the magnetic field in the primary winding collapses. Because the field collapses much faster than it is built up, it induces a high voltage in the secondary winding of the coil. These high voltage impulses, generated every time the points open, are sent through the remainder of the secondary ignition circuit to the spark plugs. In the breakerless inductive system, the sensor and trigger wheel replace the points, condenser, and distributor cam. The sensor is a small, finely wound coil which receives an alternating current signal from the electronic ignition control. It is, very simply, a metal detector. The sensor detects the metal teeth of the trigger wheel. Whenever the leading edge of a trigger wheel tooth lines up with the center of the sensor coil, a signal is sent to the electronic ignition control. The signal, shown in blue, causes the electronic ignition control to interrupt the flow of current through the primary ignition circuit, just as the breaker points do in a conventional ignition circuit. When the primary ignition circuit is opened, the magnetic field built up in the coil's primary winding collapses and induces a high voltage in the secondary winding of the coil. The remainder of the secondary ignition circuit operates exactly the same as the conventional inductive ignition system. After the trailing edge of a trigger wheel tooth passes the center of the sensor coil, current is allowed to flow through the primary circuit. The magnetic field is then built up for the generation of the next high voltage impulse. Now go to your specifications booklet and complete exercise number 1. Restart the projector when you are finished. Although breakerless inductive ignition does not require periodic replacement of ignition parts, except spark plugs, it does require periodic maintenance to ensure optimum performance. Every 12,000 miles, or once a year, whichever comes first, the spark plug should be changed and the complete ignition system inspected. The ignition system inspection is basically the same as that performed on conventional ignition systems. First, inspect the low-tension wiring. Replace frayed or damaged wires and make sure all the terminal connections are clean and bright. Next, clean and inspect the distributor cap and rotor. Replace any cap or rotor that is cracked or has excessively burned or corroded terminals. Then, add 1 or 2 drops of light engine oil on the felt wick located under the rotor. Inspect the trigger wheel and sensor for damage. If either of these components are damaged, the distributor will have to be removed for repair on the bench and calibration on a distributor tester. Detailed step-by-step instructions for bench repair and calibration on the distributor tester can be found in International Truck Service Manual CTS 2665 and CTS 2636 for 1974 vehicles. Next, inspect and test the continuity of the secondary ignition cables, including the coil-to-distributor cable. Replace cables that are brittle and cracked, show deterioration, or have excessive resistance. Make sure the cable connectors seat firmly in the distributor cap and coil and on the spark plugs. After any visible problems are repaired, connect an oscilloscope or dwell meter to the engine. It's important to note that only tachometers and dwell meters equipped with inductive pickups will work accurately unless the tester has been modified by the tester manufacturer. Make sure your tester is equipped to handle electronic ignition before continuing this test. With the proper test equipment connected to the engine, start the engine and let it run at the specified curb idle and observe the dwell reading. On 1975 vehicles, the dwell must read 26 to 32 degrees. If it is not within specifications, stop the engine and adjust the trigger wheel to sensor air gap. All 1975 engines equipped with electronic ignition should operate with a trigger wheel to sensor air gap of 8 thousandths of an inch. 1974 systems must be checked at 2,000 distributor RPM, which is actually 4,000 engine RPM. The dwell should read 25 degrees plus or minus 3 degrees at 2,000 distributor RPM. In 1974, the air gap is 14 thousandths of an inch plus or minus 2 thousandths. To set the air gap, rotate the trigger wheel until one tooth is aligned with the center line of the sensor. Then measure the air gap between the sensor and the end of the trigger wheel tooth with a clean feeler gauge. Loosen the sensor mounting screw and move the sensor to obtain the specified air gap. 1974 vehicles have the sensor mounting screw epoxy glued in place. It is recommended that the breaker plate be removed when loosening the screw to prevent epoxy chips from fouling the centrifugal advance mechanism. Tighten the sensor mounting screw and recheck the air gap. After the dwell is properly adjusted, check the remainder of the ignition system on the oscilloscope. Observe the spark plug firing voltage, spark plug variation, secondary cable resistance and insulation, and coil output. Replace any of the parts that are defective or not within recommended tolerances. Check the timing with the distributor advance vacuum line disconnected and the engine RPM set at the specified idle RPM. Reset the timing and idle speed if necessary. Excepting the sensor and trigger wheel, the routine maintenance procedures for breakerless inductive ignition systems are basically the same as those required for conventional ignition systems. Recommend to your customers that they have the spark plugs changed and the ignition system checked on an ignition oscilloscope every 12,000 miles or 12 months, whichever comes first. Now go to your specifications booklets and complete exercise number 2. Restart the projector when you are finished. The remainder of this program deals with troubleshooting and repair of electronic ignition. The electrical components of the ignition system, the sensor, coil, and electronic ignition control, are not repairable. If any of them are found to be bad, they must be replaced. You'll have to obtain 4 pieces of equipment to troubleshoot the system. You'll need a DC voltmeter, a 12 to 18-inch long jumper wire with clips at both ends, a distributor sensor substitute tester switch, which is special tool number SE2503, and insulated pliers for handling high-tension cables. Use the voltmeter to check the battery. A fully charged battery should read 12 to 13 volts. If it is not fully charged, charge it, or if necessary, replace it. Visually inspect the primary wiring and secondary wiring for damage, deterioration, or defective connections. Replace any defective wiring before you continue with the test procedure. Next, make certain electronic ignition control mounting bolts are tight to maintain proper grounding. Grasp one of the spark plug insulator boots and remove it from the spark plug using a firm twisting pulling motion. Insert an extension adapter into the spark plug connector. Using insulated pliers, hold the end of the extension adapter about 1/2 inch away from the engine block and have an assistant crank the engine for you. If a spark jumps the gap, the ignition system is working properly. If there is no spark, reinstall the spark plug cable and proceed to the next step. Disconnect the high-tension cable from the coil terminal tower and the distributor cap and check its resistance. If it is within specified limits, not over 15 kilo ohms, reconnect the coil end. Clip one end of the jumper wire approximately 1/4 to 1/2 inch from the metal connector at the distributor end of the cable. Ground the other end of the jumper wire to the engine block. Now crank the engine and observe the spark between the jumper wire clip and the ignition cable terminal. If a spark occurs, the problem lies in the distributor cap, rotor, or spark plug cables. Replace the faulty part and recheck the spark at the spark plug terminal. If no spark occurs between the jumper wire clip and the cable terminal, go on to the next step. Disconnect the distributor primary wiring connector nearest the distributor and plug the SE2503 tester switch into the primary side of the connector. Turn the ignition switch on and press the tab on the tester switch. If a spark occurs between the jumper wire clip and the ignition cable terminal, the distributor sensor unit is faulty and must be replaced. If an SE2503 tester switch is not available, you can use a new sensor unit in its place. Simply plug the sensor unit connector into the harness connector and pass a screwdriver in front of its metal detecting surface. This procedure will simulate pressing the tab on the SE2503 tester switch. If no spark occurs at the jumper wire, proceed to the next step. Disconnect the distributor primary wiring connector from the electronic ignition control and plug the tester switch connector into the ignition control connector. Turn the ignition switch on and press the tab on the tester switch. If a spark now occurs between the jumper wire clip and the ignition cable terminal, the primary wiring between the distributor and the ignition control is bad and should be replaced. If no spark occurs, take the tester switch out of the system and reconnect the primary wiring between the distributor and electronic ignition control. Then continue to the next step of the test. Connect the positive lead of the voltmeter to the positive terminal of the coil primary wiring. Clip the negative voltmeter lead to the engine block. With the ignition switch on, the voltmeter should read battery voltage. If the voltage is noticeably lower than battery voltage, a high resistance exists between the battery and the coil terminal and should be repaired. If the voltage at the coil equals the battery voltage, go on to the next step. Connect the voltmeter positive lead to the coil negative terminal and the negative lead to the engine block. Plug the SE2503 tester switch into the primary wiring harness connection nearest the distributor, as in the preceding sensor test. With the ignition switch on, the voltmeter should read 5 to 8 volts. A reading under 5 volts or over 8 volts indicates a defective coil, which must be replaced. With the ignition on, press the tab on the tester and observe the voltmeter. The voltage reading should increase to battery voltage. When you release the tab, the voltage should drop to 5 to 8 volts. If the voltage does not switch up or down, the electronic ignition control is faulty and must be replaced. If the voltage does switch up and down and no spark occurs between the jumper wire clip and the ignition cable terminal, the coil is faulty and must be replaced. If the module is found to be bad, always replace it with the same color module. The gold 1975 module can be used on 1974 systems with no ill effects. But the black 1974 module does not provide a voltage input signal needed to trigger the deceleration throttle modulator valve used on 1975 vehicles. After you have replaced the faulty parts, recheck the spark at the spark plug terminal. If the system is operating properly, the spark should jump a half-inch gap between the cable extender and the engine block. Now go to your specifications booklet and complete exercise number 3. Restart the projector when you are finished. Let's review the basic operation of international electronic ignition. Very simply, breakerless inductive ignition operates much the same as conventional inductive ignition systems, except the wear-sensitive breaker points, condenser, and distributor cam are replaced by a non-wearing sensor, trigger wheel, and electronic control unit. Electronic ignition eliminates periodic replacement of distributor components and theoretically should last the life of the vehicle. You have also been shown the recommended maintenance procedures specific to breakerless inductive ignition. Impress upon your customers that the system needs service every 12,000 miles or once a year, whichever comes first. At that interval, the spark plugs should be changed and the entire system inspected both visually and electronically. The program has also covered the step-by-step procedures for troubleshooting the entire system. Following the procedures outlined in this program and in your specifications booklets will help you systematically isolate faulty components and repair them. The 1974 and 1975 systems are basically the same, but there are some minor differences. The gold color electronic module used on 1975 vehicles can be used on 1974 vehicles. The black electronic module used on 1974 vehicles will operate the ignition system on 1975 vehicles, but does not produce the voltage input signal necessary to trigger the deceleration throttle modulator system. The dwell angle on the 1975 system is 26 to 32 degrees and is constant throughout the entire engine RPM range. It can be accurately measured at idle speed. The trigger wheel to sensor air gap on 1975 systems is 0.08 of an inch. On the 1974 system, the dwell angle is 25 degrees plus or minus 3 degrees, measured at 2,000 distributor RPM. And the trigger wheel to sensor air gap is 14 thousandths plus or minus 2 thousandths of an inch. When using a test stand for distributor calibration, the test stand should be modified in accordance with the model year system being tested. Always refer to the appropriate service literature for the model year being serviced. Tools and instrumentation for both systems are the same, but to obtain accurate readings, the tachometer dwell unit must be modified for electronic ignition unless it is of the inductive secondary pickup type. Additional service information can be found in International Truck Service Manuals CTS 2665 and CTS 2636.